Very warm welcome to IDEA StatiCa release webinar. Hope you can hear us and see us. This is IDEA StatiCa team broadcasting about what is coming in IDEA StatiCa version 10, what has actually arrived for IDEA StatiCa version 10. I can see some people are still joining in. Thanks a lot for the interest. It's myself and two of my colleagues. My name is Juraj Shabatka, and I've got two of our product engineers, Vít and Lukáš, with me today. We've prepared lots of content, live examples, a little bit of theory, what's new, and we're going to be using GoToWebinar because there's quite a crowd here. We've put everybody on mute. You can see on the right the ribbon to set up your audio settings and to type in questions. You can type them in any time. We will be answering continuously, and at the end we'll cover some of them, hopefully all of them, to so everybody knows. And if we miss something, we follow up with an email no later than the next day. Version 10 of IDEA StatiCa. I'm going to talk a little bit about the highlights. Then Vít will cover the steel part, Lukáš the concrete one. I will then have a small bonus for you and just make sure everybody's on the same page in terms of licensing, downloads, installation. In steel version 10, we finally have done the seismic checks, the capacity design. It was one of the last showstoppers or our little pains in terms of computational capacity of IDEA StatiCa connection. So version 10 has this possibility, and it's up for you to deep dive into connections where the seismic checks are relevant. We've improved some of the manufacturing operations. Of course, checked all the BIM links and linked applications we have to ensure compatibility. And we've also expanded the set of codes. It's not just the US, Eurocode, Canadian, Australian. It's also Russian now, fully implemented in IDEA StatiCa connection. And there is that bonus I will talk about later. That's a new application of IDEA StatiCa, which can do a little bit more than just the connections. In concrete, we focused on the rebars optimization. You will see how IDEA StatiCa detail can help you get your designs to pinpoint accuracy while keeping on the safe side. Also, lots of new templates to speed up the work. We've also worked on the BIM operability and the ability to work with batch of data in our IOM interface. So I'm gonna hand it over to Vít, who's gonna talk more in detail about steel.
In a few next minutes, we will go through all new features for steel applications in IDEA StatiCa version 10. So let's do it. First thing, we implemented a new capacity design analysis for the seismic check for seismic areas. You can input a dissipative item or choose a dissipative item, and you can perform the code check with a slightly different approach, for example, with usage of strain hardening factor, etc. And the plastic hinge occurrence can be seen. So it's our new capacity design analysis. I will show you a practice example in a few minutes. Next thing, local deformation check. We implemented local deformation check for all hollow members only, for pipes, for SHS beams, or for rectangular hollow section beams. The limit is 3% default by code. Of course, it can be changed by user. We prepared a new Russian design code into IDEA StatiCa connection according to SP16 design code for steel-to-steel joints only. We implemented the code checks for plates, bolts, preloaded bolts and welds. Also, we prepared detailing checks for bolts. Steel grades and bolt grades usual for Russian market are implemented, and also typical Russian cross sections are implemented into IDEA StatiCa connection library. We spend quite a time with updating the manufacturing operations. For example, we improved a stiffener for the welded cross sections. Now the stiffener will change its dimensions accordingly for the bottom flange, which is smaller than the upper flange, for example. Next one. There is an update in the MitraCut operation for stiffening members. Stiffening members can be now easily connected to the members on both sides by this MitraCut operation. Again, improvement in the cut operation for the hollow members. Hollow members are now cutted by a true outline of the plate if the plate is aligned with the member. We spend some time on the Kedling's update. For example, there is a better detection of the welds longitudinal to the beams. And now let's proceed to practical demonstration of our capacity design. I prepared for you this kind of pre-qualified joint. It's a beam connection to column, and I have it open here. So let's proceed right into the application. Let's say I'm an engineer and I prepared this joint to pass the code check for stress strain analysis, which is the first step, and I'm satisfied. So then I will create a copy to keep that data, and now I will turn to this capacity design analysis right here at the top. Now I have some new features here. First step will be to insert the loads according to my calculations, and I calculated the loads in this way. So my bending moment for seismic analysis is this one. So let's apply it on the beam, and according to my bending moment, the shear force must be inserted. And of course, I want two load effects with opposite acting forces, so I just changed the direction. Right now, in another step, we will choose the dissipative item at the top, and we will choose it for the beam IPA 360, because I think the plastic hinge will occur here at the beam, just slightly ahead of this stiffener. And one of the last things, the stiffener is approximately 360 millimeters in the distance from the beam, from the center of the joint, from the node. So I need to fill this value here as a position. And last thing, I will change the model type for the beam because I want to have deformation only in a vertical plane of the beam itself. So great, that's it. We can turn on the calculation and let run the iteration process. As you can see, the analysis tries is trying to find the equilibrium, and we can see that it's not so quick because it's a little bit overloaded, and you can see that the percentage is dropping down. The application is trying to find the equilibrium in smaller increases of the applied loads. And right now we can see that our joint didn't pass the code check for the capacity design. Okay, what else? We have to do some changes in the design. Okay, I will increase the thickness of the end plate, and I will add a stiffening plate, the doubler, on the web of the column. Just give me a second. I will turn these operations on. With these welds, I will weld this doubler to flanges on both sides, and I will cut these stiffeners with the doubler. And now my modification is done, and I'm sure right now it will pass the code check for the capacity design. And you can see the calculation is a little bit more quicker now because the equilibrium is there. And right now we have our results here. So the connection passed the code check, our plates and bolts are okay, and we can, for example, check out where is the plastic hinge on the beam. And you can see that it occurs right behind the stiffener as we expected, and we are satisfied with this behavior. This is the end of my practical demonstration, and I will pass the word to my colleague, Lukáš.
Thank you, Vítě, for word, and I will continue with the concrete part. I hope you can see my screen. Oh, sorry. And now it's time to kick off news version 10.0 for concrete. So at first, I please the bridge engineers because we have developed templates of the diaphragms in a detail. So as you can see, we prepared a box girder diaphragm, multi-cell box girder diaphragm, directly and indirectly supported double T diaphragm. As a second part or a second big developed was rebar optimization. So we will show the real practical demo, and the rebar optimization is a tool which is finding out the minimal amount of the reinforcement in a detail and trying to optimize and design the reinforcement which will be fully utilized. And the third one is our EOM. It's IDEA open model was extended by the data for the check of the reinforced and pre-stressed cross sections using RCS application. Interface of the program contains almost all data used in RCS application. And at the same time, the library where the user can call the third-party applications and launch the checks and to read the check results what's created. Results will be in the EOM format. So now let's jump into the first practical demo, and I will show you diaphragm templates. I will select a multi-cell box girder diaphragm. So I will jump in directly to the IDEA StatiCa application. I will select IDEA's our detail application. and I will create a new project. And as you know from the wizard, we have the fourth one is the diaphragms, and now here you can find all these four topologies of diaphragms. So I will select a multi-cell box girder diaphragm where some default reinforcement will appear, and you can edit geometry and opening and everything what you want on this detail. So at first you can optimize your shape by the coordinates. You can see here are some coordinates where you can edit your shape, because this is some polygon from the DXF reference. You can edit also rounds or openings in the detail. You can move it by the coordinates or related it to the master and insert point. And you can also change the point support. We prepared the loads. So what was the, let's say, hardest topic? Because as you know that the cross section of this type of the diaphragm, or the type of the cross section of this type of the bridges, so all forces are transferred through the walls. So we prepared for you some free load cases. The first one is some basic self weight of the structure, which is interpreted as a line load in the wall or in the center line of the cross section, which is interconnected with the mass of the diaphragm. The second load case is some superimposed dead load, which is as well imagined by the line loads. And the third one, which is the most critical or the most demanding, is the shear stress flow, which is presented by the stress flow in the center line of the box girder cross section, right? Okay, we prepared as well the combination for with the combination rule, which is from the error code. You can see all partial factors can be changed as well as in the previous templates like a beam or walls and everything else. And now we can move to the reinforcement, where we prepared for you some default reinforcement, which is parametric design, and you can move or change the parameters as a diameter or number bars in a layer which are related to the edge. So you can change it and add more reinforcement, whatever you want on this detail. So I have selected only one from all of these. So now it's time to come back to the presentation, and I would like to show you our second tool, or our second development part, rebar optimization on the depth end of the beam. So I will come back to the application and create a new project, and we will start from the scratch. So I will select a beam. It's a depth end with one cross section. And you can see some default reinforcement will appear. I only elongated on the 6 meter. The depth end will be hinged a little bit. So the hinge will be right-sided, and the distance of the hinge from the beginning will be 1.2 meter. And now I only add the other discontinuities from the point of view of the opening. The opening will be circular, and the diameter will be 0.8 meter, will be in the position 0, and 0 from the point of your master point, enter insert point. Okay, now I can move to the loads where two load cases were automatically predefined. So we can jump into the internal forces where for the load case 1, the shear force will be 90 kilonewton, and for the load case 2, as a variable load, 90 kilonewton as well. And you can see that I have added or some line loads will automatically generate it, and the shape of the internal forces are automatically calculated from the shear force and the related line loads. This is the same for the load case 1 and load case 2. And now I will come back to the loads and switch it off the combination for the serviceability limit state, because the topology, no topology, but rebar optimization is working only with the combination for ultimate limit state. Now I will jump into the reinforcement and I will slightly change the reinforcement in this detail. So we can go through the input and edit and remove this incline bar. This bar in the middle, the longitudinal bars in the middle of the detail will be removed as well. And the GB1 reinforcement, I have to remove it as well. Now I would like to add some rebars to the bottom edge. So I will add a new group of bars, but it will be related to the more edges. I will select number 4, 6, and 1. 4, 6, 1. And you can see this is the shape of my reinforcement. I will change the diameter and change the number bars in a layer. Now I don't know if this detail passed the checks or not. So I will run a rebar optimization, and I would like to, or you are engineers and you have to define what you will optimize. So I would like to optimize only this rebar. So check it on and run the optimization analysis. This is an iterative process which is coming out from the combination rule from the ULS and is finding out the minimal amount of the reinforcement which transfer the applied loads in this combination. Okay, now you can see that the optimization recommended to me that the minimal 4 bars in the layer with diameter 20 will transfer my load. So I will change it. You can see the utilization is approximately 93%, and now I can go through the check and run the nonlinear analysis where only the combination for the ultimate limit state will be calculated now, and I hope that the results for the reinforcement will pass. Okay, now you can see the reinforcement will pass on the 95.9%. So it's all from my side, and I will pass the presenter to Juraj, and he will continue in the presentation.
Thanks a lot, Lukáš. Thanks a lot, Vít, for great presentations. Thanks to everybody for holding to us through the technical glitches. I guess that's one of the dark sides of doing the webinar live. And we'll try to reward you with the bonus that no one has seen before. In the version 10, there's a possibility to test our new application, to test its beta version of our new application called IDEA StatiCa Steel Member. Why we developed it? It is relatively easy to code check and design simple beams and columns, but it's it gets very interesting in evaluating constraints at the ends, changes of beam depths, all the openings, irregularities, load eccentricities. And buckling is an issue. So we've took the method inside IDEA StatiCa connection and put it into an application that can work with and code check beams and columns. So you are able to do your global analysis in SAP 2000, StatPro, other applications like that. Take the selected members and their internal forces. Of course, do the connections in IDEA connection, but then run the lateral torsion buckling analysis for the whole component, get the critical load factors, buckling shapes, slenderness capacity, all what you need for a code check for that whole member. We spent some time on this, and this beta version is the first version of the application. It's not public. If you want to test it, you want to become a beta tester, there's a survey after this webinar, and you can indicate that you want to become a beta tester of IDEA StatiCa Steel member. If you do so, we're going to send you instructions how to do that. You will have the possibility to play with the application. Not everything is done for 100% in terms of all the teeny little details, but it gives you a perspective of what this can do. And it gives you possibility to tell us what you think. We've created a short survey at the end of the testing procedure. So I encourage you to do so and become the part of the influencers of what we do. Version 10 is already out. Most of you have already downloaded it. We released it a couple days ago, and when you go to our website, it's in the downloads section. IDEA StatiCa 10, we always keep the previous version 9. They run simultaneously. Okay, upgrading, moving to version 10 is very simple. You download the setup of version 10, you launch it. It tells you that license was not found. You click on yes, and then you click on download license file. It automatically updates your license file configuration, and you are good to go. Only if this does not work, please let us know either through your reseller or directly to us, and we're going to take a look into it. Okay, very well. We've covered quite a few questions during the presentations. Let me do at least a few. So this one is on you, Vitek. What material diagram? I'm sorry, that's on Lukáš. What material diagram is used for rebar optimization?
Okay, so I will take a presenter and I will show you. Now I will come back to the presentation, and I didn't mention that we are using for the optimization bilinear diagram with the hardening. And this is the best way for the rebar optimization because you receive the full capacity from the optimization. The bars are utilized on the approximately 100%. So we are using bilinear diagram with the hardening from the point of view of the plastic branch, hardening of the plastic branch, right? So
very well, thank you. I've got some questions if the procedure for the license update is also valid for the network licenses. It is the same. The only exception is if you're running our advanced licensing system using a special dongle, then it's different, but most of it's the same. So just to follow the simple procedure. One more from Steel, Vitek. Strain hardening factor is different in our national annex. Can I change it?
Thank you, Rai, for the word. Yes, of course, you can change it because we believe that the capacity design analysis, the procedure is the same for whole the world, but according to the nationality, sometimes can vary the factors. And yes, due to this, you can easily change all the needed factors in IDEA StatiCa connection.
Very well. Thanks a lot. We have suggestions for some new bin links in the discussion. Well noted. Thank you. Let me take the presenter back. As you probably know, we do lots of our webinars regularly. So allow me to just update you on what is coming. Actually, in May 15, we're going to do a Connection Wednesday. And later, a week later, there's going to be a webinar on the concrete. We're going to dig into ULS checks, strength anchorage, everything you need to co-check concrete members, not just the simple ones. Thanks a lot for coming. If we've missed your question, we're going to follow up via email and make sure you know to where we are headed and how to make your project safe and effective. Thanks a lot and have a good day. Bye-bye.
Bye
Have a
bye.
nice day. Bye.